Yeah, so we'll have a basic overview on the dyno setup as well as the vehicle part. So in the dyno setup, major thing we can see is the mechanical fixture for the overall dyno part. So we have an elevated system. We have a ramp also to get the vehicle inside the dyno setup. So inside here, so just under the wheel, we have an inertial load, that is a roller which is made of casted MS steel. So it is in the other side there is a speed sensor connected to it. In this side there is an inline torque sensor just after the roller shaft. After the roller shaft there is a torque sensor. After the torque sensor there is a motor, that is a dyno motor, which is acting as a load. And this motor wires are directly connected to the setups inside the dyno rack, that is a motor controller. So that is, and the dyno setup is also, we have kept a lot of cushy foots under to avoid any of the vibrations that is coming from the vehicle in the dyno setup. So we can see several cushy foots mounted all in the bottom.
So vibration isolators.
Yeah, basically vibration. Usually they use it in the basic generators and things. So it's a similar kind of setup. So coming to vehicle, so vehicle is currently a two-wheeler vehicle, and it is a battery-powered electric vehicle which also has a motor and with an inbuilt transmission, and it is connected to the rear wheel. And it also has a motor controller which can do both motoring as well as region. But region by default it is just with the inertial based region, not anything command based. And the vehicle also has a logger inside, so which will log certain parameters which is happening in the vehicle. And we have also left out a USB cable which can be connected to any of the computer system, and we can get the log files. And the vehicle is equipped with self-driven, so we also have the vehicle application installed inside the dyno rack, inside the PC. So once we open the vehicle application, we can do the drive cycle simulations depending on, we can also do manual command, we can set the manual speed manually, or we can load any drive cycle and make it run in an automated fashion. So that is part of overview on the vehicle and the dyno setup. If you have any doubts, we can.
Okay, so once it's finished, I think there were some calculations. So how did you get the answers? We want to know the calculation and the programming that you did.
So that motor is the same motor like this real DC motor.
Yeah. So that has an internal gearbox. So it's kind of different motor than this, not the same motor.
In the manual, can we get the information, those components, what are the different components?
Yeah. We'll provide there'll be like 3D because we are the ones who designed it. So we'll briefly explain what parts it is.
Just the name of the component, model section.
So regarding vehicle, regarding dyno.
If you mention, we can get it in the website. Whatever the information is there. For example, if you mention the name of the component,
So we'll give you the data sheet also.
that's it. We can get the information.
So some of the components we only manufacture. For that you won't get data sheets. For that we'll specify the specifications. So something we have used directly from the market will give you the data sheet.
So this motor controller battery, the motor, those data which is displayed in the panel is not accurate actually.
No,
When SOC is not
yes.
correct.
So that is not part of the
But if
the data we need to consider from that
turned
part.
on and it is displaying, if it is accurate, it will be good. Even if you take the vehicle out, as you said, I can drive in a different terrain and drive cycling, then how I will visualize my speed.
No, even if you take the real market vehicles, usually they'll have a minimum, according to RI, minimum 4%.
My point is
they'll
SOC
be
itself is not showing. State of charge is it is not showing.
Not showing.
Display. Yeah. See, if I disconnect with this system, if I take it out as an individual bike, I can't able to look after the exact value.
And if it is not properly
you're not supposed to take it out in the
it is running
road
on this
also.
drive cycles. I want to test my own driving. I want to take out the log file. It is possible, right?
Yes.
then the data which is collecting, it is displaying in the panel, it is not accurate.
Which
For example, speed. Once we operate, I'll tell you. The speed of the vehicle, state of charge is not displaying. As a vehicle.
So once again, it is not a road legal vehicle. You are not
Yeah,
supposed to take it
no,
out in the road.
At least in
For example,
Yeah.
in the test track, if you try to ride it,
Maybe-
you can collect the data. If in the test track, if I
So
can.
data will be there, correct?
Data, yes, you told that last time.
No,
But
that
I think
will
log
be
file,
You want to check physically.
log file is collecting some
Conformity,
data.
conformity for that data to be
Ah.
accurate, we can give it.
Calibrated,
No, no,
not
no,
calibrated, I think you told.
Log file is collecting this DAQ system, collecting the DAQ system, right? Collecting the data, 13 data associates. Whether it is accurate or not, if we display, it should display there also. No?
No, it is. It doesn't.
For example, I'm riding in 40 km speed. It should be 40, right?
That variation will be
Then,
there.
which data is getting stored, we cannot visualize, right? If I want to drive in 40, I
no
want to feel
relationship.
it.
There is no relationship between what is there, showing there, and what is being logged.
Then we cannot test it in the road. You just correct it, we'll see.
Yeah.
Once you operate, I'll tell you.
Invitation ಕೊಡೋದು ಈಗ ಸುಮ್ಮನೆ ಡಿಸ್ಟರ್ಬ್ ಮಾಡ್ತೀರಾ
Possible.
ಮೀಟಿಂಗ್ ಐತೆ ಏನು ಮಾಡೋದು
So we'll send a message to Sriram. We'll send a message to see Vijay.
Okay, sir. No problem. Even the last meeting.
So you can continue, sir. Now. Yeah, recording. There's no pause in
So
this.
I'm just okay. I'm just opening the application.
Stop it and again.